Alright guys, good morning or afternoon, depending on which class you're in. So we are going to be finishing up solving by factoring today. It's going to be very similar for the most part to what you saw on Friday. However, there is one difference, and hopefully you've noticed it. In all of these problems, there are now 3 numbers instead of just 2. So here's what has happened. When we factored the other day, a was always 1, so my number with x squared. Every single time it was 1. In this case, it's not going to be. So let's look at what we can do in order to help ourselves factor when we have a number out front that isn't 1. The first thing I need you to do is there is actually a typo in example A. If you will go ahead and change the sign in front of the 90 to be a plus instead of a minus. With that in mind, if I was going to solve letter A by factoring, the first thing I notice when I look at these 3 numbers right here is that 9 and 63 and 90, all of those can be divided by 9, okay? So I'm going to go ahead and do that just to make my numbers smaller and easier to deal with. So if I divide 9 by 9, I get 1, so that leaves me with 1x squared. If I divide negative 63 by 9, that leaves me with a negative 7, and my x is still there. And if I divide 90 by 9, that leaves me with 10. Equals 0. So I've started to factor. I'm not done yet. But what I've just done is I've left myself with something in parentheses that is a lot easier to work with. So now I go and I draw my x. C, or the number by itself, still goes on top. So that's a 10. And negative 7 is going to go on the bottom. So now I'm looking for 2 numbers that multiply to positive 10, add to negative 7. Well, that's negative 5 and negative 2. So be very careful when you write your factors down. One of the biggest mistakes people make when they write out their factors, they forget about the 9 out front, okay? That hasn't disappeared. It's still going to be there. It's just kind of been separated from the other numbers. So 9's out front. And now I write my other 2 factors, x minus 5 and x minus 2. So if they ask me for factors, I'm done right there. If they actually want solutions, though, I've got to take each piece and equal it to 0. So 9 equals 0 because 9 is a factor. X minus 5 equals 0. And x minus 2 equals 0. Well, the last 2 are easy to solve. If I add 5 to both sides, I get that x equals 5. And if I add 2 to both sides on the last piece, I get x equals 2. But something kind of strange is going on up front with this 9. I have the statement 9 equals 0. Well, that's never going to be true. So here's the thing. 9 is a factor. 9 is not a solution. Quadratics should only ever have 2 solutions. So that 9 should stay out front, but when you actually go to solve, it should not be part of your final answer. Okay? All right, so that's if I can factor something else out that they have in common. We are going to skip example B just for sake of time. So let's go look at example C. Oops, hit the wrong button. There we go. Okay, so example C. The first thing again that I'm going to check, this is equal to 0, so I'm good there. I'm looking to see if there's anything that I can pull out of 6, negative 13, and 6. And in this case, there isn't. There is nothing that goes into 6 that also goes into 13. So I've got to do something a little bit different. Make sure you're paying attention because you've probably never seen this before. Okay, so since I can't pull anything out, I go ahead and I draw out my x. Here's what's different though. Because I can't get rid of this 6 out front, it's also got to go in my x. So instead of just putting the number by itself on top of the x, I'm going to do a times c, 6 times 6, and I put a 36 on top of the x, not just a 6. However, the negative 13 on bottom does not change. So what changes is I multiply my first and my last number together, my a and my c, if I can't get rid of that number out front. So now I'm looking for 2 numbers that multiply to 36 and add to negative 13. Well, that is negative 9 and negative 4. Okay. And again, this next step is also going to be a little different. When you write out your factors, I have to remember about that 6 again. When I write my factors, it's not going to just be r minus 9 and r minus 4. That's part of it. It's going to become r minus 9 over 6 and r minus 4 over 6. Okay? So everything that you're doing has that first number in mind. It should never completely disappear. Okay. From here, I look at those fractions and I say, can they reduce? And you can type those in your calculator. Well, 9 over 6 reduces to 3 over 2. And 4 over 6 reduces to 2 over 3. Okay. My very last step here to complete my factors is called the bottoms up method. So if, after I reduce these fractions, there is still a number on the bottom, I take that bottom number and I swing it up front. So the final way that you would write your factors would not be r minus 3 over 2. I take that 2 and I swing it up front so that it's 2r minus 3 and 3r minus 2. There's my factors. I cannot leave a fraction in my factors. Okay? So now from here everything's exactly the same. If I want to find my zeros or my solutions, I take each piece of this right here and I set it equal to 0. So 2r minus 3 equals 0 and 3r minus 2 equals 0, and I get r by itself. Okay? Well, when I get r by itself, when I solve these two equations, I get r equals 3 over 2 and I get r equals 2 over 3. And then I'm done. So factors are what's in parentheses. If they ask for factors, you stop here. If they want solutions, I've got to go a step farther, set each piece equal to 0, and solve it. Something you should notice though, even though my answers are fractions, they do still have opposite signs from my factors. My factors were negative, my solutions now are positive. So let me give you one more example of this. If I look at example D, I always first check, is it equal to 0? And it is, so I'm good there. Now I'm going to look and see, is there anything that goes into 15, 4, and 3 that I can pull out? And in this case, there isn't. So I'm just going to go ahead and draw out my x. Okay. So because I couldn't get rid of that 15 out front, I have to put it in my x. So it's not just negative 3 that goes on top of the x this time. It's 15 times negative 3, which is negative 45. But 4 still goes on the bottom. So your bottom number doesn't change. It's just the top number that changes if I've got a number out front. Okay? So now I'm looking for two numbers that multiply to negative 45, add to 4. Let's see, and that would be 9 and negative 5. Okay? So now I'm ready to write my factors, but again, I can't forget about this 15. When I write my factors, it's not just a plus 9. It's a plus 9 over 15 and a minus 5 over 15. So everything that I do should involve that 15. Okay? So as I look at these fractions, I notice they can reduce. So let's go ahead and do that first. 9 over 15 will reduce down to 3 over 5. And 5 over 15 will reduce down to 1 over 3. And again, guys, if you struggle with reducing fractions, if you will hit alpha y equals in your calculator, type in that fraction. When you hit enter, it will automatically reduce it for you. Okay? And at this point, I am ready to do our bottoms up method. So I take the bottom number, so in the first one that's a 5, and I swing it up to the front. So instead of leaving it as a plus 3 over 5, it now says 5a plus 3. Same thing on the second one. I take the 3 on the bottom of the fraction right here, and I swing it up front, bottoms up. So that becomes 3a minus 1. There's my factors right there. If I want solutions, I take each piece, set it equal to 0. And I I'm not going to go through the process of solving these right now, but if you do solve them, you get negative 3/5 and positive 1/3. And then you're done. And so again, my factors had opposite signs for my solutions. That's one way to double check yourself. Make sure that you haven't made a mistake somewhere. So go ahead, get started on your practice, and let me know if you have any questions.